So, in this lecture, we're starting on chapter 3 of Hibbler. So, in chapter 3, we're talking about it's all about equilibrium for a particle. So, when we're talking about equilibrium, we'll define when the acceleration of a particle is equal to zero, the particle is in equilibrium. That was defined by Newton's first law. And Newton's second law states that if the force is equal to mass times the acceleration, if the acceleration is zero, the force, the total force applied to a particle must be zero. Okay. So if a particle is in equilibrium, we can always say, so if a particle is in equilibrium, we may always say that the resultant force, which is equal to, or the net force applied to the particle, which is again just equal to the sum of all the forces on the particle, must be equal to zero. Okay, so we're going to use this relationship to solve for any unknown forces that are being applied to our particle. So in order to solve our equilibrium equation, we'll need to use a tool called a free body diagram. A free body diagram allows us to easily apply all of our equilibrium equation. So the goal of a free body diagram is that we will first isolate a particle from its surroundings, and then we'll identify all the forces that are acting on the particle. So you're going to use this technique throughout most of your mechanics courses. And then once you have a particle is isolated, you can define you'll define the known forces that are being applied to the particle, and you'll define the unknown forces being applied to the particle. And then the last thing that you'll do is you'll use the equilibrium equations to solve for the unknown forces. That concludes this video on the equilibrium condition for a particle and the introduction to a free body diagram. We're going to go through some examples at the end of in the next couple of videos on how we'll apply the equilibrium condition and the free body diagram.